Alright, so Unit 25, Screw Thread Specification. Introduction. Screw threads are used in a variety of mechanical applications. They may be used to transfer motion, transmit power, or fasten parts together. Threaded fasteners such as nuts, bolts, and screws are perhaps the most common application of screw threads. Screw threads may be internal or external and are available in a variety of diameters, shapes, fits, and so on. Therefore, all information needed to fully understand the thread requirements must be specified on the drawing. So, screw thread definition: a rigged uniform section of a form of a helix on the internal or external surface of the cylinder or hole. So, that would be your actual thread. So, you got your major or nominal diameter, the diameter of the thread as measured across the crest of an external thread, and the root of an internal thread. You got your minor diameter, which is the smallest diameter of a screw thread or nut. Pitch is the distance from point on a screw thread to the corresponding point or next thread. Angle of thread is the included angle of the thread. Crest is the top of the major diameter of the thread. Root is the bottom of the major diameter of the thread. Thread depth is the distance from root to crest of the thread. Axis is the center line running lengthwise through the screw. And then pitch diameter is an imaginary cylinder that passes through the threads at a point where the width of the thread and the width of the groove are equal. So right in the middle. Alright, screw thread profile or form. So screw thread form refers to the shape of the screw thread as it appears in the profile view. A number of screw threads forms are used in various industrial applications. The form selected often depends on how the screw thread will be used. So buttress, Acme, unified and metric, and then worm. So unified inch screw thread form is, or unified thread form as it is often called, has a 60-degree included thread angle and is the common thread form used in the United States. Canada and Great Britain, the unified thread system is specified the most standard internal and external thread applications for holding, clamping, or assembly. It is also the thread-through thread system specified most often on engineering drawings in this text. Metric screw thread form is the unified inch thread served as the prototype for the metric or M series thread form. Therefore, the profile of the united and metric threads is the same. Buttress threads are designed to handle extreme weight and transmit power in one direction. They are capable of handling heavy lifting applications. Heavy-duty automotive jacks is a good example. Then you got Acme thread forms are very strong and are used to transmit power and motion. A large flat of the crest and root characteristics of Acme threads. Typical applications for Acme forms are lead screws, vice screws, machine tables, and slides. Then you got a worm gear, or worm thread, is a thread or special form of thread that is similar in shape to an Acme thread. In application, a cylindrical worm thread shaft engages the threads on a mating part called a worm wheel. As a worm shaft rotates, it causes the worm wheel to rotate as well. Worm wheels are used primarily to transmit power and motion. Standard screw thread series. Thread series refers to a group of diameter pitch combinations applied to specific thread diameters. In simple terms, a thread series is a way of distinguishing threads based on coarseness or fineness pitch of a thread, as stated previously. Unified inch screw threads are most frequently used for internal or external applications in the United States, Canada, and Great Britain. The unified inch thread series, along with the ISO metric threads, are universally used around the world in manufacturing and everyday applications. So unified inch screw threads are comprised of 11 series that can be used. 3 of the series, the unified coarse, unified fine, and unified extra fine, have graded pitches, while other 8 series have constant pitches of 4 UN all the way to 32 UN threads per inch. In all examples, the UN is the abbreviation for unified, while the other destination of the constant pitch series is the number of threads per inch, despite the numerous choices available. And the preferred thread series for the most general applications are the UNC and UNF. So UNC is Unified Core Series, generally used for the majority of the screw, bolt, and nut applications. The coarse thread allows for rapid assembly and disassembly and is recommended for general use in machine construction. UNF is Unified Fine Series, which is recommended for applications where high strength is required. Unified Fine thread or less thread depth of the unified coarse thread and is often used in situations where a hole might have thin walls, such as threading a hole and tubing. Unified Extra Fine Series is recommended where thin-walled material is to be threaded and where depth of thread must be held to a minimum. For example, thin-walled tubing or thin nuts. They are also frequently used in adjusting screws where fine adjustment is required. And then you got Constant Pitch Thread Series, used for special design applications where the same pitch is preferred regardless of the diameter of the thread or shaft or hole. The 8-pitch thread series, for example, has 8 threads per inch for all diameters and is generally used on bolts for high-pressure pipe flanges as well as cylinder head studs. Metric M Series Thread Series. The metric M Series thread is used universally worldwide, although the use of unified threads in the United States remain approximately 65%. The use of metric threads is increasing. The characteristics of metric M Series threads are the same as unified inch screw thread, with one major difference. The dimension and tolerances of unified inch screw threads are given in inch units, while the metric M Series threads are specified in millimeters. So your classes of fit. Screw thread fit refers to the amount of allowance and tolerance between mating threads. There are 3 classes of fit and can be assigned to internal and external M Series and unified inch threads. Each class of fit specifies the required tightness or looseness between threaded components. 3 classes of fit. Designations for unified inch screw threads are class 1, 2, and 3A for external threads and 1, 2, 3B for internal threads. The class of fit designations for metric threads are tolerance grades and tolerance positions. 8G, 6G, and 4G are for internal threads, or external threads, and tolerance grade, tolerance position of 7H, 6H, and 5H for internal threads. The metric tolerance grade is indicated by a number. A number 6 is a standard fit. Numbers greater than 6 specify looser fit, and numbers lower than 6 specify tighter fit. Upper and lowercase letters are used to identify the material limits for the crest and pitch diameters. An uppercase letter identifies the thread as internal, while a lowercase letter indicates the thread as external. An uppercase H is a standard for most applications. Unified Inch Series, Class 1A for external threads and Class 1B for internal threads. Metric tolerance grade for position 8G for external threads and 7H for internal threads. So, a loose fit. Recommended for only screw thread work where clearance between mating parts is essential, for rapid assembly, and where shake or play is allowed. It's going to be Unified Inch Series Class 2A for external and 2B for internal. And then your metric is going to be tolerance grade in position 6G for external and 6H for internal. Then you got standard fit, which is representing a high quality commercial screw thread product. It is recommended for great bulk and general screw thread applications. So Unified Series Class 3A for external, 3B for internal. Metric would be tolerance grade in position 4G for external threads and 5H for internal threads. So then you got a tight fit, which represents an exceptionally high grade commercially threaded product. It is recommended only in the cases where high cost and precision tools and continual checking of tools and product is warranted. So, unified inch screw specification. A system of letters and numbers are used to specify screw threads on engineering drawings. The sequence followed for unified inch screw threads is as follows and shown in figure 25.3. Decimal, nominal, or outside diameter of the thread, decimal, or the number of threads per inch, thread form, thread series, class of fit, internal thread A or external thread B designation. Left-handed thread LH designation is not required for right-hand threads. So 0.75 is your nominal diameter, 10 is your number of threads per inch, UNC is the thread series, 2 is the class of fit, A is the internal or external thread symbol, and then if it's left-handed, it'll have an LH at the end. So, metric screw thread specification. The order and method of the metric M-series thread specifications differ somewhat from the United thread specifications. The dimension requirements and tolerance grade and tolerance position may be difficult to understand for those having limited knowledge and experience with metric screw threads. The general explanation for the grade and position tolerance was provided for the class of fit descriptions. The sequence for specifying metric M-series screw threads is as follows. Metric symbol M, and then the nominal diameter of thread in millimeters, your lowercase x, pitch millimeters, and then number and letter specifies the thread tolerance class designation for the pitch diameter. The number and letter specifies the thread class designation for major diameter and external minor diameter for internal threads. And then left-handed thread, if it is that, it is not required for a right-handed. So same thing, metric symbol, nominal size, pitch, tolerance grade, tolerance position, then tolerance grade, tolerance position on the last. So, specified of left-hand threads. Threads may be cut as either right-hand thread or left-hand thread. When right-hand thread is specified, no symbol is put on the drawing. When left-hand thread is required, the symbol LH is placed at the end of the thread specification for both unified and metric threads. And then here would be your assignment.